Hello aspiring DevOps engineers, welcome to this comprehensive interview prep series. This right here is going to be a classic, so make sure you stay focused, go through the different episodes, and I promise you, we're going to be dropping a lot. But sincerely, I've just had a lot of luck with Glassdoor. Most of my jobs came from Glassdoor or LinkedIn, and since this is a series, we'll start with Glassdoor, and for the upcoming videos, we can use other platforms where necessary, enabling communications between VPCs across different accounts or regions, maintaining isolation while facilitating the exchange of data. Employing Amazon Route 53's global traffic management capabilities will also be a good idea. I will design a scalable domain name system to route incoming traffic to the nearest available region or availability zone, optimizing latency and fault tolerance. Additionally, I will set up Amazon CloudWatch for robust monitoring of resources, ensuring early detection of issues. For data persistency, Amazon RDS, a managed relational database service, will be implemented for structured data, while Amazon DynamoDB will handle non-SQL requirements, both offering built-in replication and multi-availability zone support for durability and failovers. I would also explore Amazon Virtual Private Networks or AWS Direct Connects for secure and dedicated network connections. Moreover, Amazon's CloudFront's content delivery network capabilities could be harnessed to cache and deliver content globally with low latency. In conclusion, the solution will entail a well-architected combination of IGWs, PGWs, ELBs, ALBs, VPC pairings, subnets, possible VPNs or direct connections, as well as CloudFront meticulously configured across multiple availability zones for high availability and fault tolerance. This intricate orchestration, along with robust monitoring through CloudWatch and strategic DNS routing via Route 53, ensures a scalable, resilient, and reliable infrastructure. Question number 2. Tell me about a project you participated in from start to finish, preferably one on AWS, and feel free to provide me with all the services you used. If asked that question, I'll say, oh, that's a nice question, because I just completed a multi-tier fintech project on AWS that I led from inception to completion. The goal was to create a scalable and secure application that handles financial transactions, users' accounts, and real-time analytics. In terms of architecture, the front end was built using React and hosted on Amazon S3. To ensure global responsiveness and low latency, we leveraged Amazon CloudFront for content delivery and caching. For the back end, we adopted a microservice approach orchestrated by EKS. Dockerized microservices ran across EC2 instances, including user authentication through Amazon Cognito, transaction processing, and analytics. Data storage comprised Amazon RDS for structured user and transaction data, and real-time analytics were achieved using Amazon Kinesis streams with Lambda functions, feeding aggregated data into Amazon Redshift. Security was paramount. We relied on Amazon Cognito for user authentication, network security groups to regulate tier communication, Amazon CloudTrail for audit logs, and Amazon CloudWatch for monitoring infrastructure and applications. Our CI/CD pipeline was set up using Amazon Code Pipeline and AWS Code Build, integrated with infrastructure provisioning through Amazon CloudFormation and Terraform. Automated testing, building, deployment, and Kubernetes cluster updates were triggered by code commits. To address scalability, Amazon AKS auto-scaling was implemented, and both Amazon RDS and DynamoDB allowed for flexible database scaling. We ensured high availability using Amazon Route 53's multi-region redundancy and Amazon Aurora for database replication. Monitoring and observability were achieved using Amazon X-Ray for request tracing and Prometheus and Grafana for Kubernetes cluster monitoring. Despite challenges, as optimizing database throughput and orchestrating complex EKS microservices, myself and the team succeeded in delivering a secure, scalable, and high-performance fintech solution on AWS. This experience, among several others that I've had within the past 6 years, has provided me with a lot of experience and expertise when it comes to AWS services. Question number 3. Are you just familiar with AWS? And if not, how do you ensure high availability in multi-provider cloud environments? If asked that question, I'll say, oh no, my current role entails using all 3 providers, and I'm familiar using AWS, Azure, as well as GCP. High availability to me involves just designing a system to minimize downtime. In multi-provider cloud environments, this requires distributing resources across different providers, regions, or availability zones. Load balancing, failover strategies, and automated scaling plays crucial roles when it comes to achieving high availability in my current environment. Question number 4. Can you explain the concept of immutable infrastructure? If asked that question, I'll say, immutable infrastructure is a practice where servers and its components are never modified after they're deployed. Instead of updating existing instances, we create new ones with the desired changes and replace the old ones. This approach enhances reliability, predictability, and simplifies rollbacks. This usually will be a good instance where you can implement your blue-green deployment. Question number 5. What is the role of monitoring and observability in DevOps? If asked that question, I'll say, monitoring involves tracking systems metrics and performance, while observability goes beyond by allowing us to understand the internal state of the system from their external outputs. Tools like Datadog and Prometheus and Grafana helps collect metrics, analytic logs, and provides insights into the system's behavior and performance. Question number 6. Imagine you're in charge of maintaining a Linux server that's hosting a critical web application. Unexpectedly, the server experiences a complete shutdown and your suspicion leans towards a potential CPU-related problem. In this scenario, your primary objective is to swiftly troubleshoot the issue and restore the web services to ensure minimal downtime and disruption. What would you do? If asked that question, I'll say, thank you for asking that question, because although our services are built to be self-healing and reliable, every engineer has faced a specific issue. So I'll start by going to AWS to see if the instance is actually running or not. If the instance is up and running, I'll establish remote access connection using my SSH terminal or remote desktop. Once in the server, I'll monitor for CPU usage using commands like the top command or stop. This will be my first step of troubleshooting, as it will help me pinpoint the processes causing high CPU consumptions. I'll then check for system logs using syslogs. This will provide insights into potential CPU-related errors or hardware issues. If the problem persists, I'll utilize hardware diagnostic tools to detect hardware failures, particularly CPU or memory related. Simultaneously, I'll restart essential services like the web server or databases if excessive CPU usages led to the shutdown. Another easy way to determine what the issue is by checking out Datadog or the CloudWatch alarms. Implementing resource monitoring tools for continuous CPU and system performance tracking is crucial for identifying abnormal behaviors promptly. For servers in a load balance setup, I'll reroute the traffic to other functional servers, maintaining service availability during troubleshooting. Overall, if you go through physical assessments, remote access monitoring, log analysis, hardware diagnostics, service restart, I believe most of the times you'll find the issue and bring back the service up. Question number 7. As a DevOps engineer, do you work on documentation or is it done by somebody else? If asked that question, I'll say, as part of my role, I'm responsible for developing comprehensive documentations related to various processes, configurations, and deployments. These documentations play a crucial role in ensuring consistency across the team and enabling effective workflows. I have actively participated in creating documentations that outline deployment processes, infrastructure setup, and configuration steps. Additionally, my experience with specific tool stacks have allowed me to contribute by crafting guides and tutorials that cover best practices, troubleshooting techniques, and optimization strategies. These contributions not only benefit my team, but also aids in disseminating knowledge through the organization. Furthermore, I'm involved in documenting the incident response and solutions. Whenever issues arise in the production environment, I document the steps taken to diagnose these issues and how we resolve them. The documentation serves as a valuable reference for future incidents and also supports continuous improvement efforts. Question number 8. Are you involved in mentoring and facilitating meetings within your organization? Kindly elaborate. If asked that question, I'll say, in my current role, I'm actively engaged in both mentoring and hosting meetings as part of my responsibilities as a DevOps engineer. In terms of mentoring, I've had the privilege to share my knowledge and expertise with junior team members, aiding them in professional growth and helping them understand complex technical concepts. This mentoring process involves providing guidance on best practices, troubleshooting approaches, and assisting them in developing a comprehensive understanding of the tool stack as well as technology we work with. Additionally, I play a pivotal role in hosting meetings that contribute to effective coordination and collaboration across cross-functional teams. These meetings range from project kickoffs and status updates to technical discussions on implementing new tools or resolving challenges. By facilitating these meetings, I ensure that all team members are aligned, well-informed, and equipped to make informed decisions. Both mentoring and hosting meetings are integral aspects of my current position, allowing me to contribute not only to the technical aspects of our project, but also to professionally grow in my domain as well as help my colleagues succeed. Question number 9. Have you been involved in an on-call rotation? If so, could you discuss their significance and highlight the key elements that you believe should be involved in this process? If asked that question, I'll say, yes, I'm proactively participating in an on-call rotation for my current role. On-call rotations are a critical component of maintaining reliability and availability of the system and its applications. They ensure that someone is readily available to respond to any incidents or issues that might arise outside regular working hours. This proactive approach reduces downtime and minimizes the impact on the end user side. In terms of key elements for a successful on-call process, effective communication is paramount. Clear documentations outlining escalation procedures, incident response protocol, and the contact information for the relevant team members is essential. Furthermore, having a robust monitoring and alerting system in place enables quick detection of the abnormalities, allowing the on-call personnel to address potential issues promptly. An organized knowledge base with the past incident response and the best practices is also valuable for effective troubleshooting. Regularly reviewing and updating the on-call process based on the lessons learned from the past incidents contributes to continuous improvement. Ultimately, a well-structured on-call rotation fosters a culture of responsibility, teamwork, and constant improvement, ensuring the seamless functioning of the critical system. Question number 10. Could you discuss an achievement that you take pride in and that has become noteworthy in your present position? If asked that question, I'll say, certainly, I'll be glad to. In my current role as a DevOps engineer, one accomplishment that stands out and I take immense pride in is the successful migration of a complex multi-tier application to a cloud-based infrastructure. This project involved meticulous planning, collaboration with a cross-functional team, and a deep understanding of both the application's architecture and the cloud technologies. By orchestrating a migration, I not only ensured a seamless transition but also optimized the application's performance and scalability, leading to a significant reduction in the response time and increased user satisfaction. This achievement showcased my ability to manage intricate technical challenges and work in a collaborative team setting. It has become a noteworthy accomplishment in my role, underlining my commitment to enhance system efficiency and drive successful outcomes for the organization. Question number 11. Could you elaborate on the monitoring stack you've deployed in your current position? Additionally, how do you guarantee efficient alerting and incident management using your monitoring system? In my current capacity as a DevOps engineer, I've overseen the implementation of a comprehensive monitoring stack that plays a crucial role in maintaining the health and performance of our systems. The monitoring stack encompasses various tools and technologies tailored to our specific infrastructure and application needs. We utilize a combination of Prometheus for metrics collection, Grafana for visualization, and ALK Stack for log aggregation and analysis. These tools provide real-time insight into our system's behavior, enabling us to promptly identify abnormalities, performance bottlenecks, and potential issues. To ensure effective alerting and incident response, I meticulously configured alerting rules in Prometheus that triggers notifications based on predefined thresholds. Critical metrics such as CPU utilization, memory usage, and response time are continuously monitored, and alerts are sent out to the designated person on call via Slack or emails. Additionally, I employed incident response automations where specific alerts trigger the predefined playbooks that outline the step-by-step procedures for resolving common issues. This automation minimizes human error and accelerates incident resolution. Regularly reviewing the monitoring stack has really helped me to fine-tune the system for accuracy and relevance. We conduct post-incident reviews to refine alert thresholds and respond procedures based on the lessons learned. This proactive approach ensures that our monitoring not only detects abnormalities, but also aids in mitigating them swiftly, contributing to the overall reliability and scalability of our system. Question number 12. Could you describe the best practices you adhere to when crafting Helm charts to guarantee both consistency and reusability? If asked that question, I'll say, when it comes to creating Helm charts, I prioritize several best practices to ensure both consistency and reusability across the deployments. First and foremost, I emphasize modularity of the Helm charts. By breaking down complex applications into smaller manageable components, we enhance the chart's reusability and maintainability. Each component, such as services, configurations, persistent volumes, is encapsulated within its own chart, promoting flexibility. Moreover, I advocate for parameterization of values. This allows us to customize deployments using Helm values.yaml files. By parameterizing key configuration aspects, such as environment-specific settings and credentials, we avoid hard coding and facilitate smooth deployment across different environments. To maintain consistency, I follow version control practices diligently. Our Helm charts are stored in version control repositories, enabling us to track changes, collaborate effectively, and ensure that the chart aligns with the corresponding application version. Lastly, documentation plays a pivotal role. I create clear and comprehensive README files accompanying each Helm chart. In conclusion, the best practices I adhere to while crafting Helm charts focuses on modularity, parameterization, version control, and thorough documentation. By following these best practices, we foster consistency and reusability, leading to more effective and reliable deployments across our infrastructure. Question number 13. Could you explain your approach in maintaining image versioning, ensuring security, and optimizing image sizes within Docker? If asked that question, I'll say, to begin, I'll meticulously handle image versioning by adhering to semantic versioning principles. This allows for clear tracking of changes and ensures that updates are comprehensible and predictable for the team. Obviously, security is a paramount concern, so I will adopt various practices to enhance it. One key aspect is utilizing trusted base images from official repositories, as these images are frequently updated with security patches. Regularly scanning images using security tools like Clear identifies vulnerabilities, enabling timely patching or replacement of the affected images. To take it a step further, I'll implement image vulnerability assessments as part of our CI/CD pipeline, ensuring that only secure images are deployed to production. Optimizing the image sizes is another crucial element. I'll employ a layered approach using multi-stage builds to reduce the size of the final image. This approach eliminates unnecessary components from the final image and results in a smaller footprint. Additionally, I will minimize the number of layers and remove redundant packages and files to further optimize the image size. Question number 14. Could you share your practical experience with Jenkins and how you utilize it to facilitate continuous integration and continuous delivery processes? If asked that question, I'll say, of course. In my role, I have hands-on experience with Jenkins, utilizing its robust capabilities to streamline continuous integration and continuous delivery workflows. Jenkins serves as a cornerstone for our CI/CD pipeline, automating key stages of our software delivery process. For continuous integration, Jenkins orchestrates the integration of code changes from various team members into shared repositories. This includes running automated tests, static code analysis, and other validation checks as well. This ensures that the code changes are thoroughly validated before merging them, maintaining code quality and preventing regression. In terms of continuous delivery, Jenkins is instrumental in automating the deployment of our application changes to our staging and production environment. Through defined pipelines, I configure Jenkins to deploy artifacts, execute necessary configuration updates, and manage environment-specific variables. This consistent and automated process minimizes manual intervention, reducing the potential of human error and ensuring reproducible deployments. Moreover, Jenkins enables real-time monitoring and reporting for our CI/CD pipeline's health. This transparency aids in identifying bottlenecks and optimizing the pipeline's efficiency over time. Regularly updating and versioning Jenkins plugins is part of my routine to ensure we're leveraging the latest features and security patches. In summary, my experience with Jenkins revolves around leveraging its features to streamline continuous integration and continuous delivery. It facilitates automated testing, validation. It's important to tailor your answer to your experiences and background. While the job might not offer the best pay for a senior role, it's a great opportunity to build experience and confidence. Stay tuned for our next videos where we'll tackle another job posting and its technical interview questions. Happy studying, and remember,